Welcome to this channel once again, and today I am going to demonstrate how to find the true length of a line when a line is neither parallel to horizontal plane nor to vertical plane. So if a line is parallel to horizontal plane, then we'll get the orthographic projection of the line of the same size what the line has. Or if the same line is parallel to vertical plane, again you will get the orthographic projection on vertical plane of the same size what the line has. But when line is neither parallel to horizontal plane nor to vertical plane, then you have to do some geometrical construction. So today I am going to demonstrate step by step how to find the true length of a line when the line is neither parallel to horizontal nor to vertical. So for today's class, let's focus on example figure P4.2. So first what I will do, I will draw this question first, then I will explain how to find the true length. So let's focus on it. So in first step, I am going to draw a reference line. So let me see the question first. So I am going to draw a line OX, which is a reference line. So I draw a reference line OX. Don't bother about the length of the reference line. The length is not important here. It is just a reference line. Then again, now I am going to draw C prime D prime, which is the orthographic projection of a line on the vertical plane. So to do so, what I will do, I will take any reference point here, and from this reference point, I will go up 10 mm because it's 10 mm. So let me draw a line from any reference point, and to measure the length, I will use a scale here. So I will draw from 0 to 1. So it will be 10 mm. Then let's see what is the distance between this point and this point. This is 30 mm. So now I'll move rightwards 30 mm. So to measure 30 mm, I will again rotate the scale. Measure 30 mm from here. So 0 to 3. Now I'll draw another vertical line from here. But I don't know how to draw a point here. I don't have a much more idea how to draw a point. So what I'll do, I'll draw a line so I'm going to draw another line with different color, but you have an option. You can use different you can easily measure from here to up to 3. So for you don't need to draw a line again here. You don't have to repeat this line, but I don't have much more option, so I draw another line to just locate this point. Now from this point I'll go up 40 mm. So I'll draw another line here from up to 40 mm. Now I'll join this point and this point. Then you'll get A prime B prime. So you can simply draw a line from here up to here. Okay, so let me use black color here, otherwise people get confused. So this is A prime B prime. Similarly, we'll draw AB as well. So let me see. So this distance is 14 and this is 31. So what I will do, I'll draw a projection line from here. So it is 14 mm and this is 31 mm. So let me use the scale once again. So it's a 40 mm, 14 mm, not 40. Uh, so from 0 to this is 14 mm. Similarly, we should draw another line here. It's a 31 mm. So this one is a 31 mm. So so I draw a line having length 14 mm and 31 mm. But you have option. You can directly draw a line, projection line from here of any length, and then you can measure this 14 and 13 mm. Now join these points. So this is AB. Now you transferred your question. Now in next step, I am going to rotate this line. So I am going to draw an arc with a center, this one, A prime, and radius A prime, B prime. So to do so, I use compass. You can also use compass. So you can locate the needle here, and this is your radius. Now make an arc. Length of arc is not important here again. Then we should draw a line from this point parallel to reference line. So this is the line. This is another construction line. It is parallel to OX. I don't know whether it is exactly parallel to OX or not, but let's assume it's parallel. Then again you should draw another projection line from the point of intersection of arc and this line. So I am going to draw another projection line from here, from this point of intersection. Okay, so before that I'm just going to, okay, let me draw another projection line here. And the length of this line is not important. Again, it's a projection line. Then again you should draw another line parallel to OX from this point. Now we should draw another line from this point up to this point. Now once you join this point, sorry, this point and this point of intersection, I think it's not perfect. Let me make it perfect. So you should join this point and this point, and this line is the true length. The length of this line is true length. So you should simply measure with the ruler. Let me measure it. So let's measure. So approximately its length is, let's say, around 45 mm. So this 45 mm is the true length of that line. And the angle made by this true length with this horizontal axis, with this reference line, is the theta v. And similarly, you can rotate this line and you will get theta as well. So now I'm going to repeat the same procedure, but now this time I will start from AB, not from A prime B prime. So we'll repeat the same thing, and whatever the true length you'll get, that length is similar to this length, and whatever the angle made by this line with horizontal axis, this will be your theta h.